All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So for the factoring, you're going to start off by taking this 14 and multiplying it by the 3, so that you have x squared minus 13x plus 42. We remove the 14 by multiplying it by that 3. And then when we factor, we're going to replace the 14 that we removed. And so the two numbers that we want to use are going to be -6 and -7. And then we reduce. The 14 and the 6 will reduce by 2. So we'll have 7x minus 3. And then the 14 and the 7 will both reduce by 7. And so we'll have 2x minus 1. And so this would be your answer for your factoring. For the math knowledge question, it tells us that the measure of each interior angle for an n-sided polygon is n minus 2 times 180 divided by n. So I'm going to write that here. N minus 2 times 180 and then divided by n, where you have n number of sides. And so we have a pentagon in this figure, so that means that our n equals 5. Because a pentagon has 5 sides. So when we plug it into our formula, 5 minus 2 is 3. So we have 3 times 180 and then divided by 5. And so if you multiply that out and then divide by 5, you're going to get 72 degrees. So each of these angles here is 72 degrees. So if that one is 72, we want to find the rest of the angle. Well, this part over here is going to be 360 minus 72. And so if you subtract those, you're going to end up with 288. And so that would be your answer for the math knowledge question. So today we are looking at lesson 67. We're doing introduction to transformations. So hopefully after this lesson you will understand some translations and transformations. So transformation is a change in position, size, or shape. So there are a lot of different transformations that you can do. You can change the position, you can change the size, or the shape. Or you can do more than one of those. But a transformation is always going to change either position, size, or shape. Or it could change the position and the shape, or the size and the shape. But it's going to have to do at least one of those. Translations, reflections, and rotations are examples of a special class of transformations that are called isometries. So translations, reflections, and rotations are called isometries. The original figure in a transformation is called the pre-image, and the shape that results from the transformation is called the image. So the figure that you start with is the pre-image, and the figure that you end with is called the image. An isometry is a transformation that does not change size or shape of a figure. It only changes the position. So the ones that we're going to look at today are only going to change the position, not the size or the shape of the figure. Only the position. An isometry is also called a congruence transformation or a rigid transformation. Since it doesn't change the size or the shape, the figure stays rigid. It doesn't get smaller or bigger. It's rigid. It's firm. It doesn't move. The angles or the side lengths don't move. They stay the same. It can be called a congruence transformation because the two images, the pre-image and the image, are congruent to each other. All we have done is changed where it is located on a coordinate plane. The small apostrophe marks, or tick marks next to T, U, and V, they're right after the T, the U, and the V. There's one here. That's called a prime. That's read as V prime. This one here is read as U prime. And then this one here is read as T prime. The blue figure that we have drawn here is our image. The black one is called our pre-image. So we took this figure and then we moved it and made this new image. And the two triangles are still congruent. This triangle TUV is congruent to triangle T prime, U prime, and V prime. So a translation or a slide is a type of transformation that shifts or slides every point of a figure the same distance in the same direction. So you basically take your figure and it just gets pushed over to here. And we pushed it by the length of this arrow or the direction of that arrow. Okay? A reflection or a flip is a transformation across a line, and it's called the line of reflection. And it's such that the line is the perpendicular bisector of each segment joining each point and its image. So if you look at the figure that they give us, this line here is the line of reflection. And if you notice, the figure on the left here and the figure on the right, they are a reflection of each other. They were reflected across this line of reflection. And if I were to draw a line connecting point C to C prime, this line is always going to be perpendicular to the line of reflection. Now, A and A prime are actually the same point. Same thing with D and D prime. But if I drew a line connecting B to B prime, it's always going to be perpendicular to the line of reflection. And all we did basically, we took our figure over here and it got flipped over to this side. So a reflection or a flip. Then a rotation or a turn is a transformation about a point that's called the point or the center of rotation. So you can say the point of rotation or the center of rotation. Either one works. But you turn it or rotate it about that point such that each point and the image are the same distance from that point, and the angles formed by a point, its image, and the point of rotation, where the point of rotation is your vertex, are congruent. So what that means, let's look at A and A prime. If we take a point and its image and then the point of rotation, this angle that's formed here, whoops, that's not such a great line. This angle that's formed here is going to be the same as if I used D prime and I made an angle here. That angle and this angle are going to be the same angle. So all of those angles, and I could do the same with point B and C with their B prime and C prime. But the angles that I would make by connecting are always going to be the same. Okay, so that's a rotation. So we want to identify the type of transformation that's illustrated in each of the pictures. So I want you to take a second, y'all can pause the video if you need to, and try and figure out what each of these is going to be. So this first one, we take A, if I reflected it across a line here, that would mean that A prime should be over here. Since A prime is not over here, that means that it's not a reflection. Okay, so this is not a reflection. This is actually a rotation. Okay, that one is a rotation. This one here, we just took our figure and we pushed it down. We slid it down. That is called a translation because we just slid it down a little bit. And then this bottom one, they even drew in the line of reflection. So it's called a line of reflection. It's called a reflection. They're not always going to draw the line of reflection here, but if you look, we have a figure, and it does kind of look like it was slid over, except for the fact that they labeled our points. We have W and W prime right here. Those are right next to each other. If W prime had been over here, then it probably could have been a translation. But if you notice, W and W prime are right here next to each other, and so that's not going to be a translation. That's going to be a reflection. Okay, looking at this next one, we want to rotate the figure about point L. So the way that we do that, you see this arrow here. We are going to rotate it that far, okay? So our figure is going to end up looking something like this. Now this point here is still going to be L prime because L was right here and it stayed in the same spot. J is going to become J prime right here. And then if I follow around, this next point is going to be N prime, and then this last one is going to be M prime. So those would be your new vertices. Okay. Looking at the next one, we want to translate the figure as indicated. Well, this one doesn't indicate that it was a turn or rotation. It's just a slide. It pushes it over this far. So we're going to draw a P. That's not a very good straight line. Let's try again. And so there's my P, and I translated it. They don't have any vertices labeled, so we don't need to label anything. And I do realize that my figures aren't the greatest. I am using my little slate, so it's a little bit not quite as straight of lines as I would like, but you get the idea, hopefully there. But that's how you would translate it. And since we don't have any vertices, again, we don't have to label anything on this one. Looking at this one, we want to reflect the figure across line FG. So this is one that people frequently get mixed up. This line right here, FG, we are going to draw it in. This is point F, and this is point G. So if you connect those two, you're going to have line FG. Okay, so there is line FG, and it gets reflected across that line. And so what's actually going to happen, F is going to be the same location as for F prime. And then we're going to just reflect it. And so this point here is going to be E prime. And then down here is going to be D prime. This point here is going to be H prime. And then G and G prime are going to be in the same location. They are both touching this line right here. You should not have two figures that are separated by a space. These two parts should be one whole connection. So they should actually look kind of like, whoop, not that. Let's try again. They should look pretty close to that, okay? They actually need to be touching right here, not like this one, okay? So they should have this same side on this side right here. Looking at the next example, often stained glass designers use vertical or horizontal symmetry to reduce the time it takes to design a project. We're going to reflect the template across the vertical line AB to complete the design. So the line AB goes from A down to B. And so if we draw a line up, we are actually going to have it going across that line. And now this one is a very pretty ornate stained glass design, but you're going to basically draw it out. And so I'm going to have it look something like this. But as you can see, I'm not doing it 100% perfectly. I'm not expecting yours to look identical to theirs, although some of y'all's will come close, but it should resemble it. And then you do need to make sure to label all of your variables that they gave you for your vertices. And there is a prime there for that K, you just can't really see it. And so those would be somewhat what it would look like. Okay? So let's look at the lesson practice. I want you to try and answer these. So pause the video, and then once everybody has tried them, you can unpause it and check your answers. This first one, it's just a slide. It got slid over to the right. So this is called a translation. For this next one, reflect it across GF. So GF is this point, from this point to F, this line here. And so we're just going to reflect it across. And so that is the basic shape of it. Again, I'm using my slate, so do excuse the fact that my lines aren't 100% straight. Whoop, that's not G prime. That would be T prime, and then G prime would be up here. And it says to label the image. Even if it doesn't say to label the image, you do need to make sure that you actually label it. And you need to make sure you include the little primes on your letters. Okay, on this one, we want to rotate the triangle clockwise about point Q so that Q prime and P prime are collinear with QR. So I'm going to move my figure up just a little bit. So I'm going to draw a line connecting those two. So it says that we want Q prime and P prime on the line that is QR. Okay? So I went ahead and drew a line there with the computer so that I would have a straight line. And we want to rotate it about point Q. So that means I need to move this a little bit further up here. So that means that our point of rotation, or our center of rotation, is going to be Q, because it's about that point. And so Q and Q prime are in the same place. Now, Q prime is on the line, RQ, and it also wants P prime on that line. So that means that P is going to get pushed over to here and become P prime. Okay, and so now we have one side of our triangle. And now R, P got rotated over here. R is also going to get rotated, and it's by about the same amount. And if you notice, RP is longer than QP, but RQ is not longer than either one of those. It's the shortest side. So I'm going to put it right about here. And if you would like, you can actually kind of trace it on your paper. You can draw the original, and then you can kind of turn your paper and just trace it onto your paper for the next image. So that is okay with me. If you want to trace it, you don't have to try and do it completely by hand. Okay, so that would be how you would rotate that one about point Q. This is a simplified blueprint that shows the first two floors. the floor above the second floor, the third floor, is going to be a translation of the second floor. And it wants us to perform the translation. So it's going to look identical to this second floor. So all we would do, it's a rectangle for the third floor. So we would start by making our little rectangle. And then we would have a triangle in the middle. We would have two rectangles cut into squares on the sides with a line in the middle, here and here. And then our other rectangle cut into two squares. And so there would be your third floor. And so that's the translation that you would have there. So that hopefully helps you out a little bit with transformations where you have rotations, reflections, and translations. We've got the challenge question for today. We want to reflect the triangle first across line A and then across line B. And it says to draw the reflection after each transformation. And so I'm going to show you what it would look like using the computer. So that hopefully you can kind of get an idea as to what it looks like. So we're going to reflect it. So that's a flip. Whoops, I need to duplicate it. And then I'm going to flip it. So I flipped it, and then it gets pulled about the same distance away. It's a little bit closer here than it is down here. So it's going to need to be a little bit closer. About like that. And then we're going to take this figure and we're going to flip it horizontally across line B. And so once you flip it, it needs to be such that this tip is a little bit closer to line B, and then this vertex is further away. And so that would be what the reflection across line A and then across line B would be. So hopefully you can kind of see how that works. I used the computer so that I didn't have to try and trace it using this slate. So your homework is 1 through 30 from problem set 67. So make sure that you do that tonight so that we can go over any questions you have tomorrow.